Hello, good morning students. In this lesson we are going to look at weathering in different climatic regions of East Africa. When we talk of East Africa, we are just referring to this region for academic purposes, but otherwise weathering activities in whichever part of the world are all the same. So in this sense, we shall look at the weathering in the Equatorial climatic region. We shall look at what type of weathering takes place in the Savannah climatic region. We shall look at also what type of weathering takes place in the desert and semi-desert climatic region. And then we shall also look at the weathering in the mountainous areas, because each mountain creates its own microclimatic condition. Now, let's first of all look at weathering taking place in the Equatorial climatic region. Now, for you to be able to understand what type of weathering takes place in the Equatorial climatic region, you need to know the characteristics of the Equatorial climate. The Equatorial climate, first of all, is that region where there is a high annual rainfall throughout the year. The average rainfall per annum can reach about 1,500 millimeters. Then this is also the area where the temperatures are warm throughout the year. On average, temperatures about 21 degrees centigrade. These are also areas where there is dense forest cover because of the warm temperatures and heavy rainfall. In East Africa, the Equatorial climatic region is basically located around the shores of Lake Victoria. So, now after having known the characteristics of the Equatorial climatic region, because these characteristics are basically the factors that determine the type of weathering in that particular climatic region. Now, in the Equatorial climatic region, the major type of weathering is chemical weathering. Chemical weathering is the most active form of weathering. Why? Because chemical weathering is so much active in a situation where there is heavy rainfall and warm temperatures. The warm temperatures accelerate the rate of weathering. Then the water helps to maybe produce some form of acids within the region, and these acids are the ones that produce rapid chemical weathering processes. So in this case, there is a rapid chemical weathering taking place in the Equatorial climatic region, especially around the Lake Victoria basin, because of the heavy rainfall and the warm temperatures. Then also, as I said earlier, this is a climatic region where there is a dense tropical rainforests. The dense tropical rainforests have been motivated to grow because of the heavy rainfall and warm temperatures. Now, these dense tropical rainforests produce leaves, and these leaves that happen to fall on the ground, or the plant foliages, decompose, and in the process of decomposition, they produce what we call the humic acid. Now, this humic acid combines with water. The water distributes this humic acid deep under the ground, and it is this humic acid which is distributed by water that brings about chemical weathering of many types of rocks. For example, silicates such as mica and feldspar can easily weather under this type of acid, organic acid produced from the decomposition of plant foliages. So in this case, mica and feldspar, after their weathering, produce new types of compounds, for example, oxides of aluminium, iron, and clay. Another thing is that in this climatic region, where there is heavy rainfall and warm temperatures, and there is an intensive chemical weathering process taking place, there is thick accumulation of a certain type of rock known as laterites or marl. The heavy rainfall will drain, the large amount of water, because of the heavy rainfall, will drain various types of minerals, most importantly iron and aluminium. These iron and aluminium minerals, which are being produced in the process of weathering, are drained down under the ground, and eventually it will reach to a point where these minerals are deposited underground. They accumulate in thickness. Then, after thick accumulation of the iron or aluminium compound, they produce what we call the laterites. So laterites are therefore rich in iron or aluminium compounds because of a large amount of deposits of these iron or aluminium compounds during the process of leaching. Leaching is that process by which the minerals move down under the ground in water. So when the minerals are moved downwards in water, they are deposited and they produce the laterites. So laterites are very common products of chemical weathering in the equatorial climatic region. Now, when these laterites are exposed at the surface, they harden very fast. The water evaporates, they harden very fast, and produce hard crusts deposited at the surface of the land. That hard laterite is what is known as durocrust, or cuirass. Another form of weathering, chemical weathering, mainly occurs in limestones. Limestones are easily weathered in the equatorial climatic region because the rainwater tend to combine with carbon dioxide in the atmosphere and produces carbonic acid. Now, this carbonic acid is responsible for bringing about massive chemical weathering of limestones in the equatorial climatic region. So in areas within the equatorial climatic region where there are limestones, these limestones have been weathered to produce various kinds of what we call karstic landforms. Now we shall understand in detail of what karstic landforms are when we begin to look at the landforms produced by weathering in East Africa. In the equatorial climatic region, it should also be noted that physical weathering is not so popular. Physical weathering occurs in a situation where there is very limited rainfall and hot temperatures. Now, the fact that there is there is a high amount of rainfall and warm temperatures, it means the basic form of weathering is primarily chemical weathering, but not physical weathering. Then physical weathering is also very limited in the equatorial climatic region because of the dense forest cover, which covers up the landscape and conceals the rocks from being exposed to hot temperatures. So the rocks are covered up from being hit by the hot temperatures, and therefore causes physical weathering. And that's why physical weathering is very, very limited in the equatorial climatic region. Let's turn to weathering in the Savannah climatic region. The second type of climate is a Savannah climatic region. We need to know also the characteristics of Savannah climatic region in order to be able to understand what type of weathering takes place there. The Savannah climatic region is a region where there is one rainfall season. We have one rainfall season and also dry season. So in other words, in the Savannah climatic region we have both rainy and dry seasons. Then you'll find during the rainy season the temperatures tend to drop down slightly. Then during the dry season the temperatures are very hot. Now these characteristics of the Savannah climatic region has therefore made both physical and chemical weathering to be present. Chemical weathering is very active during that period when there is heavy rainfall and warm temperatures. Then physical weathering is very active during the dry seasons when there is hot temperatures. The major type of physical weathering is exfoliation weathering because of the hot temperatures. Then during the rain season, the chemical weathering, the main chemical weathering is basically the weathering of limestone. So we call it carbonation weathering, which is brought about by the presence of carbonic acid. Then we have to also look at weathering in the semi-desert and the desert climatic region. First of all, we need to also understand the characteristics of this climatic region. This is a climatic region where there is a very low and unreliable rainfall, and temperatures are very hot throughout the year. So you can therefore see that in the Equatorial, rather in the semi-desert and desert climatic region, given the kind of characteristics that the region has, there is only one type of weathering, and that is physical weathering. And the most prominent type of physical weathering is exfoliation weathering because of the rift temperature changes, where during the daytime temperatures are hot and during night temperatures are very cold. So this brings about expansion and contraction of the rock surfaces, bringing about exfoliation weathering in the semi-desert areas. Then we also have granular disintegration, which mainly affects rocks which are made up of grains, igneous rocks which are made up of grains. The grains are heat and they expand at different rates, and when they cool down at night, they contract at different rates. So this weakens up the individual rock grains, and the rocks eventually begin to fall off individually. So that promotes granular disintegration, which is a physical weathering process common in semi-desert areas. Then also we have pressure release weathering process, which is very common in semi-desert areas. Pressure release is brought about by removal or erosion of large amount of regolith over the landscape. Weathering processes produce thick accumulation of materials, rocks known as regolith. Now this regolith lies so thick over the rocks which are below the landscape. So it means these rocks which are under the ground are compressed so much under the ground. Now when gradually the rocks which lie over the underlying rocks are removed away, then the underlying rocks will gradually begin to rise up. So as they rise up from under the ground because of the pressure release, then they develop some curved joints or cracks parallel to the surface of the rock. So then eventually this rock will begin to fracture and tear off along these curved joints. So it brings about pressure release weathering process, which is a physical weathering type common in semi-desert and the desert climatic region. So as a result of this, you will find in the desert and semi-desert landscape there are type of landscapes produced by physical weathering. For example, we have incel bugs. We have escarpments. Also, we have the peneplains, which are very commonly produced in the semi-desert area because of the physical weathering processes. However, though chemical weathering is not so dominant in the desert and the semi-desert areas, but however, in a small, at a small rate, it occurs. You can be able to notice this chemical weathering taking place in the semi-desert landscape when you observe the rock surfaces. Some rock surfaces, you will find there are some holes which develop on the rock surfaces. Those holes are known as alveolars. Those holes develop at the spot on the rock where chemical weathering has taken place. Then, though chemical weathering is limited again in the desert and the semi-desert landscapes, but you can also be able to notice that there is some small evidence of chemical weathering when you see deposits of what we call the desert varnish. Desert varnish is reddish brown to black minerals which are deposited over the landscape. And these minerals probably are deposited due to the influence of capillary attraction of water from under the ground, where large amount of minerals have been dissolved. And most of these minerals are basically silicate minerals or iron minerals. So these minerals are gradually transported to the surface by means of capillary attraction. And the moment the water reaches at the surface, the water is rapidly evaporated, then it leaves the deposit of these minerals over the landscape, and therefore producing what we call the desert varnish. So that is a weathering process in the desert and semi-desert climatic region. In summary, basically there is a physical weathering taking place there. Then we also look at weathering in the mountainous areas. You know, mountains create their own microclimatic condition. At the peak of the three major mountains, we have Mount Kilimanjaro, we have Mount Kenya, and Mount Rwenzori. The major type of weathering is physical weathering, and most especially frosty shattering, because of the freeze and thaw of water in the rock cracks. And this is as a result of the very cold temperatures at the tops of these mountains. The temperatures are very cold because of the high altitudes. Now, however, when you come down to the slopes, to the lower slopes of these mountains, where there is heavy rainfall and warm temperatures and dense forest cover, the type of weathering becomes chemical weathering on the lower slopes of these mountains. So you'll find carbonation weathering is very common, especially on the lower slopes because of the heavy rainfall and warm temperatures at the lower altitudes of these mountains. So, on average, we have looked at 4 different climatic regions where weathering processes tend to be influenced by the climate. In the Equatorial climatic region, the dominant type of weathering is chemical weathering because of the heavy rainfall and the warm temperatures. In the Savannah climatic region, the dominant type of weathering is, they are both physical and chemical weathering processes because of the occurrence of both wet season and dry season. During the wet season, there is the active chemical weathering. Then during the dry season, there is active physical weathering processes because of the hot temperatures. Then weathering in the desert region, desert and semi-desert region, there the dominant type of weathering is the physical weathering because of hot temperatures and high diurnal or diurnal range of temperatures, where you find in semi-desert and desert areas day temperatures are very hot and the night temperatures are very cold. So this brings about exfoliation weathering in the semi-desert and desert climatic areas. Then in the mountain areas, especially the peaks of glaciated mountains like Mount Rwenzori, Mount Kenya and Mount Kilimanjaro, we have physical weathering processes, especially frosty shattering, because of accumulation of water and freezing of this water in rock cracks. The water freezes because of the very cold temperatures at the pinnacles of these mountains. Then you come down to the lower slopes of these mountains. The dominant form of weathering is chemical weathering, because in mountainous areas, the lower slopes experience a very heavy rainfall and with the warm temperatures. My dear students, I want to thank you very much for opening and listening to this lesson. I encourage you to continue to study very hard now that the term is about to be opened. Please, I encourage you to read hard. Remember, according to rumor, that by December you are going to sit for your examinations. So please, I want you to read and work hard. Also, I want to wish you in this last segment of the lesson a blessed day, and I wish you a nice time. Thank you very much.